Okay, welcome back from our short break. If you're just now joining, or if you joined earlier and you came in a little late, just keep in mind that you can review these sessions on demand. So don't worry about anything that you might have missed earlier. Next, we're going to be conducting our live Ask the Experts Roundtable session, where you as participants can pull up a virtual seat at our table and ask your questions in person. So if you have any questions relating to MPC or privacy or security initiatives that might be well served by MPC, we invite you to follow the instructions that are provided below and just get in the queue and come on board and ask your questions live. And alternatively, if you prefer, you can also just submit questions in writing via the Ask a Question box noted below. So while we're getting our questions and people with those questions queued up, I'd like to introduce you to our panelists for today's roundtable. Starting with myself, I'm Frank Weiner, co-founder and president of the MPC Alliance and chief marketing officer at CPUR. Of course, the real experts are our panelists, and I'm particularly pleased to introduce Dr. Taher El-Gamal, CTO of security at Facebook. As I mentioned previously, Taher is an internet security industry veteran and a widely acclaimed cryptographer. He's recognized as the inventor of the El-Gamal digital signature scheme and a driving force behind SSL and much, much more. As you may have seen in his keynote presentation, he's very passionate about security, and he's keenly in tune with the industry from the perspective of one of the world's largest and most respected internet platforms, Salesforce. So Taher, welcome and thanks again for joining us today.
Thank you, Frank. It's good to be here.
Excellent, excellent. So next, I'm really pleased to introduce Dr. Manoush Mavahedi, research scientist at Statistics and Privacy at Facebook. And Facebook is also our platinum sponsor for today's event. Manoush has a PhD in cryptography and computer science and has considerable experience in building secure systems. I believe one of her current projects is leveraging her expertise in MPC to improve the core MPC libraries that are being used to rebuild Facebook's ad systems to be more private. So Manoush, welcome and thanks for joining.
Thank you. Thank you for the introduction, and I'm very happy to be here with you guys.
Excellent, thank you. So next, I'm pleased to introduce one of the industry's most vocal and passionate advocates of MPC, Professor Nigel Smart. Nigel's a professor within the COSIC group at KU Leuven, one of the top universities in the world, and he's a co-founder of Unbound Security, which has a long history in working with MPC. And Nigel has numerous industry recognitions, such as the Royal Society Wolfson Merit Award, 2 ERC advanced grants. He was the president of the International Association of Cryptologic Research, where he was also named a fellow. And he's a co-founder of the Real World Cryptography Conference. So Nigel, welcome and thanks for joining us today.
It's a pleasure to be here. It's been a great event so far. Hope we can top what the previous talks were like.
There you go. Good stuff. And next, I'd like to reintroduce Dr. Dan Bogdanov. Dan leads the Information Security Research Institute at Cybernetica, and he's also a board member of the MPC Alliance. Dan is the inventor of ShareMine, which is a new kind of computer that analyzes digital data without seeing the individual values. And he's been a research team lead for multiple privacy projects with DARPA, the European FP7, Horizon 2020, and others. And Dan, we thank you for joining today and for all you've done with the MPC Alliance.
Well, I'm just hoping that my MPC dreams will become a reality, and this event sure is helping.
Good stuff, good stuff. Well, similar to Dan, our next panelist, Dr. Omer Shlomovitz, is co-founder and vice president of research at Zengo, but he's also a very active and contributing member of the MPC Alliance. And Omer is one of the original co-founders of the MPC Alliance, and he leads the technical committee for us. He's very active in the MPC community, sharing insights on vulnerabilities and actively leading open source initiatives. Omer, thank you for joining us today and your considerable contributions to the Alliance and the industry.
Thank you, Frank. Great to be here.
So next, it's my pleasure to introduce my boss. Ahmed Tunkay is the CEO of CPUR, which is also a gold sponsor of today's conference. And without Amet's longstanding backing, I would not have been able to help co-found the MPC Alliance or pull together today's conference. So prior to CPUR, Amet was the CEO of Sooner, which provided secure content management for over 150,000 businesses worldwide. He held CEO and other executive roles at companies like SolarFair, Spider Cloud, Trapeze Networks, Peargains, and others. And he's just got a rich background in the practical applications of these technologies. So Amet, thank you for CPUR's longstanding leadership in the industry and support of the Alliance. And thanks for being here today.
Terrific to be here, Frank. I think my biggest contribution to this panel will be in supporting you. So, pleasure to be here. So.
No, good stuff. Well, moving along, I'm pleased to introduce Dr. Andre Lepetz, the CSO and co-founder of Nth Party, which is some really interesting privacy initiatives underway. Prior to co-founding Nth Party, Andre was a principal at Righty LLC and an advisor and member of multiple startups. And last, but Andre, welcome.
Thank you. Great to be here.
Thanks. And last, but certainly not least, is Dr. Jordan Brandt, CEO of Infer. As a technology futurist, Jordan's research and his insights on cybersecurity, AI, and robotics have been featured on Bloomberg and CNBC, Forbes, Financial Times, Wired, and other business and technology press. And so he's a guy who's connected in the industry. He's a former CEO and co-founder of Horizon Systems, acquired by Autodesk. And he was also teaching and conducting research at the Stanford University, where he was a consulting professor of engineering. So Jordan, thanks again for joining us.
Thank you much, and great to be among a great group of expert colleagues.
Good stuff. All right. So just checking in here to see if we have any participants ready to join in live. Let's see here. I've got some activity here. I'm just scrolling through. So I'm not sure if we have a person who's live ready to come on board. But if not, we've got some questions queued up that will definitely get the conversation rolling. But just double check your making sure that we have no live callers yet. Okay, great. So again, anybody who's on the call, again, feel free to submit a question through the question box, or just follow the instructions to dial in and ask your questions live. But MPC's been around for a period of time, and there's been literally decades. But it's always good to know where things stand from a standards perspective. So one of the topics that I wanted to get some discussion around is where things stand with regard to MPC from a standards initiative. And Dan, I know you've been busy on some of these fronts from an ISO perspective. But do you want to open up some discussion around where things stand, and let's open it up to others on the panel?
Sure. That's a good way to start this, given that standards is something that are usually developed when you get to mature technologies. But sometimes you also see that standards development happens so you could actually mature technologies and create certain interoperability and tell the industry that this technology now has proper terminology and you can talk about it using standardized terms. So indeed, ISO IEC, which is the International Standards Organization, has been working on MPC and MPC related standards for years now. I was the co-editor for ISO, a standard for secret sharing back in the day, about 5-6 years ago. That was published, and MPC and the related technologies have also been included in a number of privacy standards. And right now, actually, ISO is working on an MPC standard, and it's a two-part standard right now. The first standard, again, talks about terminology, concepts, types of parties, things like that. And the second part talks about constructions based on secret sharing. So that is currently under production in the cryptography working group in ISO. And it's, I think, scheduled to be concluded in a year or two, I would say. But I do know that there are other standards organizations that are working on MPC standards as well.
Yeah, no, definitely. And I know NIST has been active on that front, working with some of the crypto primitives with MPC. Ahmet, I know CPUR is definitely focused on that, and Nigel, I know Unbound, and obviously Omer with Zengo, you've been very focused on that stuff too. But Ahmet, you want to kind of kick off the discussion around the NIST side of things?
Sure, Frank. I think NIST created a project around threshold cryptography, and there's a wonderful website which they host, and it's very educational. They have some nice publications there. And back in March of 2019, they held a kickoff meeting in Germantown at the NIST main facilities to open the conversation about standardizing certain default primitives that NIST is interested in. And our CPUR is primarily in the business of cryptographic key management using MPC and threshold cryptography. So I'll just kind of speak to the special interests that NIST has around key management and primitives related to secret keys, and I'll leave it to Nigel and other folks to contribute to other stuff that NIST is working on. So obviously they're trying to cover a broad base. But related to key management and secret keys, of course, they're interested in key generation, signing, decryption with certain primitives that they have in mind using public key encryption schemes, and of course, symmetric key operations, deciphering around symmetric keys. And the whole motivation around NIST's interest in this area is really to identify the relevant threshold schemes and modes of operation for key management. It's a long journey, and in the world of startups, we generally get nervous when big bodies like NIST get involved in stuff like this, because the long-term goal of any standard is to level the playing field, which is fantastic for the industry. And the fact that MPC is at this point, I think, demonstrates that it's maturing, which is great news for all of us. Maybe I'll pass it to Nigel to talk about some of the other things that NIST is working on.
Okay, so thank you. It's a nice coverage of that. So NIST also has another standard called FIPS 140, which is really, really important, because FIPS 140 is what they use to validate security modules, whether they're software security modules or they're the hardware security modules you'll get in a bank. And FIPS 142 is it's the middle ground. It's the one that's not pure software, and it's one that's not very heavy protected, dedicated hardware. And so what Unbound Security have is that they have worked with NIST in one of the testing labs to actually get the kind of virtual HSM, or the kind of soft MPC enabled HSM that Unbound have, validated to FIPS 140-2 certification. So it's not just the threshold standards that NIST are working on. They're also actually in the live stuff that you can buy that's FIPS validated to NIST standards. They're also already MPC stuff out there. I just want to kind of end this bit on standards by kind of bringing it back to what Dan was talking about, because IEEE are also doing something like the first standard that ISO is doing. So I've got to look it up here, so getting the number right. So the IEEE P2842 working group is looking at secure multi-party computation. And it's been it's chaired by someone from Alibaba. And they're basically defining the terminology. It's defining the terminology. What does, so you can then start actually having a conversation with people about what multi-party computation is, because it's a relatively complex task. who are the parties, what are they doing, who are the input parties, the output parties, what are the security models, what are this, what are that, what are the other. And so actually that definition of terminology is in fact the first stage that you need to do on standards, which both IEEE are doing and, like Dan said, ISO are doing as well. So thank you.
Perfect. Thanks, Nigel. Omar, I didn't know if you had anything to add.
No, not at this point.
Okay. Then looks like we got a little echo action going here, but I've got some questions that have come in via the.
Frank, the only thing I'll add to that whole standards discussion, other than what Nigel mentioned around FIPS 140-2, which has been around for a number of years, I don't think anyone should hold their breath for any of these standards to really come out and basically if MPC is going to solve a problem for you, waiting for the standards is probably just expecting a bit too much, because there are lots of things that we can do today without needing standards. So my 2 cents there is this is a long journey.
Yeah, it's definitely a journey, and we've seen literally hundreds of companies are moving forward with MPC today, and so standards are catching up as always, but it will be a journey on that front. Omer, I know we've got other questions that have come in, but I'd mentioned you. I didn't know if you had any comments you wanted to add.
No, so no comments on standards.
Okay.
I joined it as the opinion that nothing to hold the breath for. I mean.
Okay, good stuff. Well, we do have a number of questions that have come in online, so let me try to scroll up here and grab one of them here. So one question that came in from Josh on Bright Talk was, how do you calculate who among N parties holds the maximum numbers without calculating the maximum number itself? So Dan, yeah, okay.
So if we still have an echo somewhere. If we go back to what Nigel was talking about in his presentation today, then it's always critical to define what the output of a computation is with MPC. You have to calculate the right thing. And it's good to remember that MPC is a general computation device, means that it can be programmed to calculate anything really. So if you just implement using a general MPC system, something that outputs who had the largest input, but not what it was, then that is something that can be implemented using the programming tools available. So it's just another program that you're running on an MPC system.
Yeah. And thanks, Dan. And Manish, I know obviously Facebook has been working with this quite extensively, actually for a number of years, but I don't know if you wanted to add any comments on top of that.
So I think Dan described it in a high level very good, but if you want to go maybe design a protocol around it, the simplest way is that you can ask everybody to secret share their inputs, and then they can run an MPC among themselves to exactly calculate and compare the inputs. And then at the end of it, the output is not the value itself, but the person who has the highest value. So it's very easy to hide what portion of the output and reveal only the portion that you want to the people who are participating in the MPC.
Yeah, no, perfect. Thanks. All right. Well, we've got multiple questions that are in the chat box, and again, I'll remind anybody who wants to ask a question live and actually interact directly with the responses from the panelists. Please follow the instructions for dialing in, and we'll bridge you in. But one of the questions that came in was, can you provide a fair comparison on the current state of the art in MPC compared to other techniques in the protection of data and use? And examples would be fully homomorphic encryption in trusted execution environments. So anyone care to comment on that one, or?
Well, okay. My talk earlier was kind of comparing these things, and I think
yes.
The point is that everything is horses for courses. So there are situations where it makes a lot of sense to use a trusted execution environment. There's a lot of cases where it doesn't. There's a lot of cases where it makes a lot of sense to use homomorphic encryption. There are a lot of cases where it doesn't. There's a lot of cases when it makes sense to use multi-party computation. However, you have to have multiple parties. So there's a lot of cases where it doesn't. So I think you can have this a combination. I think you can have this horses for courses, but they can also be used in combination. So you shouldn't think that if you have MPC, then you're not using homomorphic encryption. There are some very famous MPC protocols which use homomorphic encryption. There are so there are also places where you might want to run MPC within a trusted execution environment. There are examples where you might want to use FHE and MPC and trusted execution. If you want to release statistical data, you are going to want to apply differential privacy, no matter how you want to compute something. Just because you can compute something securely doesn't mean revealing the results is secure. So you have all these different technologies, and they can all be used in different places to preserve privacy in the whole spectrum. But I think the one that's most applicable, most general, and most deployable today is MPC.
I want to comment a little bit on something that Nth Party often has to do in the ad tech space, which is we are trying to kind of help customers navigate something that's become very popular as a solution to some of the problems in that space called clean rooms. And one of the things that vendors of clean rooms do is they often list all these technologies as features. And something that we've kind of had to do is go back and say, all three of the technologies in that question, they actually all solve the same problem. So I would almost say you wouldn't even want to compare these. And as Nigel kind of commented, they really are complementary and can be used together. The real distinction is between these techniques, which protect data during computation, and the techniques that protect data when it's actually revealed. And Nigel already commented on one example of that, which is differential privacy. So I would say that if you're looking at use cases and sort of if you're evaluating vendors, you probably don't want to be asking for comparison between MPC and homomorphic encryption. You probably want to ask, how are you using the techniques that protect sort of the data when it's revealed, typically in aggregate, like differential privacy or adding noise or de-identification, and how are they using MPC, homomorphic encryption, or trusted execution environments to protect the data while that computation is taking place.
Yeah, I might add, it's interesting to see in practice, at least at Infer, a lot of the inbound that we get is around fully homomorphic encryption. It's such a buzzword and it's a seductive concept. And then when we actually engage with the customer and understand the problems that they're trying to solve, oftentimes it's more of an MPC or federated learning combination as a solution. So I think I support what Nigel said earlier. There's no single silver bullet. Homomorphic encryption definitely has a lot of allure. But once you disambiguate and figure out what the actual challenges are the customer's trying to solve, oftentimes it's not just a pure FHE solution. It's really a combination of techniques.
An FHE solution is a multi-party solution because, as I said in my talk, you have the person who does the computation and the person who decrypts have to be different. So you already have two parties in an FHE solution. So you've got to identify those two parties. And sometimes once you've identified two parties, you suddenly realize you've got 3, 4, 5, and then you suddenly go, actually, I've got an MPC solution here that's much easier and much faster.
Exactly.
Yeah. And I know,
So
Manisha, you wanted to make a comment. Yes.
Sure. One thing I noticed when designing a system, actual system that works with billions of rows of data, is that when you have a huge amount of data, none of these solutions really scales very well, and so you have to pick like all of them for a small part of your solution. So then your solution is going to be part of a small problem, and for each problem, one of them scales better. And then you have to pick the one that scales better. For example, for private set intersection, solutions that rely on homomorphic encryption scale better. But for aggregating data, solutions that are relying on MPC scales better. So then for each part, you have one technology, and then you gather them together and build a complex system out of it. I usually have a good example from algorithms for them. For example, you have sort algorithms and you have heap algorithms. But if you want to choose the largest k element, then based on the k, you probably can choose if you sort, or if your k is small, it's better to use a heap algorithm. So then based on your input and based on your functionality, one of the solutions can do better, and then it needs experts to choose from this mix of protocols and find a whole solution and prove that it's privacy preserving.
Excellent. No, that's a lot of good discussion on the different perspectives around that. I'd kind of like to move on to another question, and it's been worded in a couple of different ways here on the inquiries, but it's basically a question of can MPC be used for things other than just data? Let's see here.
Everything is data. And data is everything. So
I think it was numerical data.
Define data.
Agreed. I misstated it. I said data, but I should have said numerical.
Define numerical too.
Yeah.
MPC
Well, in some
is a
sense,
Turing
you need
machine.
like character data and stuff like that. Well, character is just a number. Everything in the end is just a number. And if you process symbols, whether those symbols are numbers or they're characters or whatever. And I think what the audience should understand is that there's basically an automatic translation from any problem that you can write on a computer. You can automatically translate that into code that will run on an MPC engine. So anything you can compute, full stop, you can compute in MPC. Now, it might not be efficient, but it's possible. So the issue we have with current technology is it's not universally efficient. But anything you can compute, word processing, whatever, databases, whatever, can all be done within MPC.
Mm-hmm.
Yeah, Dan.
Few examples. We've implemented a Bayesian spam filter on MPC. It takes an AES encrypted email, decrypts it under MPC, runs a Bayesian spam filter, and then tells you whether it was spam or not. So underneath it's numbers, but the problems actually work on concepts like text.
Mm-hmm.
What we see in practice with our customers who are doing privacy preserving machine learning and analytics is they're typically chaining local plain text operations with MPC in our platform to transform the data into numerical inputs, to normalize the data, do feature engineering, and all those pre-processing steps that are necessary for machine learning workloads. So don't think of it as just a pure MPC, but you can also do local operations on that data to transform it in whatever manner you want for the MPC computation.
Perfect. We've got quite a few questions that have come in. I want to, and we've got a live call from Benjamin at Facebook. So if we can patch in Benjamin, that would be great.
Hey guys, question for all of you other experts is, do you think that the sort of economic factors of MPC, the increased communication or increased computation costs of things like FHE are going to really affect like which verticals or which industries see the most adoption? Or do you think that like costs are going to be driven to be negligible in the long run? How do you kind of foresee that affecting adoption?
Depends how long your long run is. Asymptotically, it's marginal, yes. But of course, asymptotically, as time goes to infinity, people want to process bigger and bigger problems. I think in terms of adoption, it's much more about value. So where is the value proposition coming from? And also where are the industries where it's easier to deploy? This might be because there's a customer push. I think you're kind of seeing that from the Facebook example. customers are wanting more privacy in Facebook. Or it could be regulatory push, where you're seeing regulators in the financial industry wanting companies to come together to process stuff, to detect fraud, etc. So you can see it coming from the bottom, but there's got to be, like in all business, right? You've got to unlock value that someone values. And if the value you're unlocking is greater than the cost, whether that be time, money, computational resources, or whatever, you're gonna get success in deployment.
Yeah. One thing that we've certainly found is that today there are use cases where the cost of MPC is already negligible. So a lot of the things that we try to do at Nth Party is just find the opportunities, where the problem can be solved with negligible cost. And just as an example, we do MPC in the browser. That's something that is possible to do today for the right problem. So I think that it certainly shouldn't be the case that companies or organizations should hesitate to investigate MPC because of these concerns, because they could probably solve problems today if you just choose the right problem.
Going back to that, that's a really good point, because one example I give every time I give a talk to different industrial groups is the following. All the press is about machine learning, because that's the sexy thing. Everyone wants to do machine learning, right? But 99.9% of all data analysis in industry is coming up with a histogram, coming up with a pie chart, because that's what managers can cope with. And so that's what gets that. So, and doing that kind of descriptive statistics is very, very easy with MPC now. And so if that's your application domain, you can easily do that.
I want to give maybe a concrete example on the opposite, on how come when MPC becomes expensive, and still, I mean, at least for our case, we build a wallet and you need to run this key generation process. Now, it took us at the beginning order of, let's say, 15 seconds to do the back and forth of communication. So this is very expensive, and it translates to losing users, right? So user on board, and then you get him to get stuck on 15 seconds now doing distributed key generation. So we needed to put a lot of effort first to reduce this time. And eventually what we've done is we managed to do some stuff in parallel. So the process of onboarding starts while the user is unaware that key management or key generation is being done at that point. But it was far from being trivial, right? We could have just locally generate the key and be done with it. So I think it's a very good question.
Yeah, if I can add to what just Omar just said, from a real world, it probably helps to separate, MPC is just a tool to go realize things that you can engineer, practical solutions for the real world. And one of the common use cases is basically digital asset wallets. And some of the mandates around these wallets are really high throughput, for example, low latency. And of course, the end goal there is always to reduce the number of rounds that you have to do in real time with MPC. Well, a nice engineering solution for that is to do a lot of the heavy lifting involved in these rounds in an initialization stage, and you'll end up with a scenario where you pre-compute some signatures, for example, and basically store those on the MPC nodes that are going to be providing signatures in real time. When you do this, I mean, you can realize a huge reduction in the number of rounds that you do in real time for MPC. And that turns out to be not only fantastic for throughput, but you can do things like air-gapped or basically air-gapped signing. Essentially, you can basically emulate how alternate schemes like multi-sig work using MPC. So the whole point of this is that engineering a solution that uses the MPC tools for a real-world problem can give you surprisingly high-performance systems. So don't think that MPC is always as a cost. You just have some clever designs, and you can come up with some fantastic solutions.
Yeah, I agreed entirely. And that was one of the comments I was going to make, which is just as we've seen in this conference, MPC is being applied primarily for two different use cases. One is to protect data from being stolen, or assets from being stolen, that type of thing. Another is the privacy preserving computation and analytics and those types of things. And while MPC is definitely more intensive than computing in the clear, in certain applications, the additional cost and overhead is trivial. And in fact, when you look at the other costs that it eliminates, it can actually totally reduce the cost of the overall solution. So
there's in the quick fire sessions earlier, one of our team members presented the case study with BNY Mellon, which is a good example of what Nigel was referencing earlier in terms of ROI. If you're managing 40 trillion in assets and using MPC and being able to collaborate with other banks reduces your fraud or increases your fraud detection rates by 20%, that trounces any negligible increase in computation costs.
Yeah. So we've got several questions that have rolled in here, but I want to ask one question. I want to make sure I get to this, and it's probably more for Taher and maybe Manoush. But before, we've got several questions in the privacy side, but I want to just come back and ask the general question for enterprises that are thinking about implementing MPC and introducing it into their company. What are kind of the practical considerations, like, Taher, and in your mind, from the perspective of a big enterprise, where would be a logical place where MPC might get introduced as part of an overall ecosystem solution? Maybe, and Manoush, with Facebook, you've obviously gone through that. I'd love to get some of your insights on that as well.
I think I can start and then give the stage to Taher. One thing that I believe happens is that the need from privacy preserving coming from the customers and regulatories. And it's very interesting to bold that need to the leadership, and they already aware of it, but you can maybe relay the information. If like engineers and researchers can relay the information better to the leaderships of enterprises, then I think when you create this need for the privacy itself, then it is easier to introduce the solution, which can be MPC, FSU, or whatever cryptographic solution to really solve that request and need. And one thing that I noticed is that the first solution, as is probably not the best solution, and then we suddenly increase the cost. And for example, for a search that or for some product that costs you cents or $1, if you run MPC without any better engineering or without really having clever on what you are doing, you probably increase the cost from $1 to $1,000. Then you have to make sure that the leadership and the enterprise understand that, okay, this is the prototype. And then when we can do a lot of clever tricks, as other people mentioned in this group, to reduce the cost dramatically and scale to larger and bigger data sizes. So then you should prepare to be very to have a slower system, to have a drawback in liveness, and to have much more bigger latency. But then when you know the problem set, then you can work. The research is very active. We collaborate with universities to generate new protocols, underlying protocols. We collaborate with industry to generate new ecosystem to reduce the cost of privacy preserving techniques. And it happens very fast. It's not like you have to wait for 2 years, but it can happen in a span of 3 months or 6 months. So start with something that's not perfect, but make it rolling, and then you can reduce the cost and latency later. Okay, so
yeah, let me just throw some ideas into this. Not all problems are the same, although we call it privacy preserving, but they're not all the same technical problem. That there is a difference between the customer and the owner of the data in many circumstances. And then there is a data processor at the bottom of all of this. So applying MPC in the privacy case is actually very difficult the way I see it. Although from a performance standpoint, I would prefer that to a fully homomorphic solution for sure. So I do not have a practical solution from any of these technologies, unfortunately, yet. I'm just trying to focus on securing the very, very secret things first. There are information and fields and databases and so on that if somebody gets a hold of, the result would not be that great. So this is really what I'm trying to focus on first. There are privacy issues, of course, and trying to use MPC to completely solve the privacy preserving kind of problems from where we stand is really, really not trivial, because our customer is not the end user. Our customer is actually a company. And the company, which is our customer, may or may not be the owner of the data. So it's a lot more complex. The definition of privacy is not exactly very, very easy to say here.
I'd like to follow up from what Tahir said. So, in my talk, I mentioned this report by Luna Ventures, who's the VC in Berlin, and they have a really, really good take on this. So their point is that actually people get hung up on privacy far too much, whereas actually most of what we're really talking about is actually using secure computation technologies to form partnerships. When we talk about privacy, we actually really mean partnerships. And how do we secure partnerships? So you saw that in the Facebook example. You saw we had the ad guy and the Facebook guy, and they had to share information to form a partnership. We see this in the anti-money laundering example, is that we're actually processing as a part, MPC is enabling a partnership. This is enabling the banks to come together to do a money laundering protection. And this forming of partnerships is actually a completely different business model, because it's allowing companies to do things that they couldn't do before. Maybe it was illegal to do before. You can't actually, in some industries, you can't talk to each other and share information because you might form it might be an antitrust thing or whatever. So actually forming partnerships is MPC is an enabling technology to a new form of business. And I think that when we talk about privacy, that's really what we mean, is partnership forming. And when we talk about key protection, we're actually securing the things that Tahir was talking about, was actually securing the core secrets at the moment. So they're kind of, what Tahir was pointing out is really at the core of what we're trying to do.
Yeah, privacy to us is satisfying privacy regulations, actually a more specific thing.
Yes.
So that the problem I want to solve is be able to tell people, yes, we satisfy all the privacy regulations under the sun. And that is really a different issue from, I can see how MPC can help solve the partnership problem. How do you apply operations on data that has been manipulated with MPC and come up with the right answers? I can see that, and that would be a very exciting day when this is everywhere. But privacy means something very specific in the answer I provided.
I do like the nomenclature of partnership enhancing technologies. Nigel, you referenced in the Lunar Ventures report. I mean, where we're seeing the most growth and really the most excitement, I think, for this whole community is enabling new partnerships that couldn't exist before. I mean, we're seeing banks partner with telcos and airlines and hotel chains where that could have never existed before because they can't share that customer data. It's unlocking new value of this data that they didn't realize before. The challenge there, of course, is they're building net new business. So they've got to figure out a new business model for these. So there's the development of the technology, the implementation of the technology, but also the realization of what do these new ecosystems mean from a monetary value.
Yeah, perfect. Yeah, and I also like Manusha's comment, which is basically, don't wait for it to be perfect. Jump in and get going, and you can find ways to improve it and get it to where you need it to be as you go too. Time is racing by on us, so I want to move on. So there's some questions that are definitely focused on the particular Facebook implementation. I'd love to get to those. But I also want to hit some of these other topics that kind of broaden the conversation a little bit more. And again, anybody who wants to get to the front of the line, dial in, and you're at the front of the line on your questions. So one of the questions is, how do you think blockchain can help MPC, and how can MPC help blockchain? Omar, I know you're in the middle of this, as is CPUR and Unbound, and many of the other members of the alliance. But Omar, you want to comment on this one?
Yeah, I want to briefly cover three elements. I would call them the good, the bad, and the ugly. So in terms of the good, we have the threshold signing, right? So this is already becoming, used by many in the industry. It's basically a way that MPC can allow, more sophisticated access structure without, but by still maintaining some privacy of the access structure itself, and provide value when you doing the communication with the blockchain. So this is definitely a very good use case. The bad, I would say, this is something that blockchain can help MPC, and this is basically providing a bulletin board. So I call it the bad because we kind of want to hide sometimes this shame that we are in MPC, we are often being heavy on communication. We need many rounds of communication and so on. So we also need a broadcast channel, which is something that, this entire communication stack is something that we usually like to hide. So blockchain is a really great way for parties to communicate with one another very efficiently. You just put the message there, your broadcast message there, and then you can take it. And finally, the ugly. So there, I'm talking about fairness. So this is an important problem in MPC that blockchain can help to. And by fairness, I mean that you want to be able to, think about, you want to run a computation and get to a point where everyone gets the output or none of them gets the output. So it's really hard to do, and there are all sorts of issues with actually doing it, theoretical constraints there. But once you involve blockchain, and there's this monetary system of a blockchain, so you can actually solve it by penalizing with money. So it's kind of provide an interesting take on how you can achieve fairness by using a blockchain and some cryptocurrency.
Excellent.
Yeah, Frank, I'll just throw in one more thing to what Omar said. So I think the question was about how do these technologies can benefit each other, and just as an example, we've been working on a number of projects, and one of them is to provide MPC as a service. Basically, this is an open platform where anybody can leverage this service and go do privacy preserving statistics or whatever they want to do. And it turns out, the basic idea behind both MPC and blockchain is really decentralized control and trust. And they're sort of synergistic in the sense that we've implemented in partnership with a company called Particia, MPC as a service on a privacy blockchain. So these things work wonderful with each other, and it's just another thing to keep in mind, where at the end of the day we're really talking about trust, and this also relates to this other question about trusted execution environments. If you can always find somebody that you trust 100%, then you need neither blockchain nor MPC, but that's not the case in the real world.
Excellent. So again, in the question box, there's a couple of different questions about Facebook's implementation, and one of the things I wanted to mention is at the conclusion of this roundtable, Facebook, CPUR, and the MPC Alliance are all three going to have virtual rooms set up where you can pop in and talk to people who are staffing that room and have specific conversations. So I'd like to defer some of the questions that came in specifically on the Facebook implementation for people to follow up in that room. So there'll be an opportunity for you to get that addressed there. There's a couple of good ones here, but let's see. Can you provide any specific application of MPC where MPC would win over a trusted execution environment?
It's very simple.
Yep.
ECDSA signing.
If you don't
ECDSA signing, you sign something in a trusted execution environment. It's so susceptible to side channels, it can be broken by undergraduate students. Whereas if you do ECDSA signing in an MPC environment, by definition, as long as your side channel is on one of the MPC parties, by definition, if you saw everything that party does, you still don't break anything. I mean, so, it really goes to what, the heart of the crypto asset security thing. TEs do not give you good security.
Yeah.
MPC is strictly more secure.
Strictly more secure,
strictly more.
And on the practical side of things, sometimes you have no control over what hardware is available. One of the things we often do is we always tell the story of one of the first things our team did was we had to support users who were running Windows XP, Internet Explorer, and had no cooperation from their IT department to install anything new. And you just got to deal with the platform you have for the software that needs to run, and MPC is purely software based.
That sounds like a hospital, because a lot of hospital equipment still requires Windows XP.
There were hospitals involved.
There we go.
We should also add that it's not always an either or, but also both and. I mean, you can deploy, in our scenario, we've seen customers deploy VMs where their private data store in trusted enclaves or in CPU environments or GPU environments. So you can use both and. It doesn't always have to be adversarial.
And Unbound, we've seen deploying MPC not within trusted execution environments, but actually deploying MPC within HSMs. Yeah. So you have MPC between HSMs. So you get like the compliance for PCI of using an HSM, plus the added flexibility, usability, upgradability, and agility that you get from using MPC. So you can, it's not either or.
Okay, perfect. So moving on, next question is, does FHE and MPC provide code integrity and code confidentiality? And if yes, can you point out specific techniques, solutions?
Okay, so just two issues there. One is integrity, by which I think you mean is, if you change the code, can you detect you change the code? So if you use an actively secure MPC protocol, then the parties will, if one of the parties decides to run a different computation, everyone dies out, which is an advantage MPC has over FHE, because that's actually quite hard to do with FHE, to actually guarantee that the person computes the thing you want. That's right. Actually, in terms of code confidentiality, now because MPC is Turing complete, okay, you might have a so-called polynomial slowdown, and you might have to worry about, if you're a theoretician, you might have to worry about, non-uniform versus uniform complexity classes, but let's not worry about that moment. You can compute anything. Therefore, you can take as input, one of the private inputs can be a program.
Your circuit.
Yeah, so you can have as input a private program. So you could, and this is, so there are some papers that have actually looked at theoretical examples with this. I refer you to one of my papers with Payman Mahassel and his student. Payman now works for Visa. There's some stuff there on having where the code itself is private. But in theory, you can do this. Whether you can do it in practice or not, that depends on your application and how complex the program is you're trying to hide. But it's much more easy to hide, to do code obfuscation in some sense, using MPC than to use obfuscation.
Of course, you can hide the bad code just as well as you can hide the good code.
That's true. Yeah, you have to trust the person who's providing the code. Yes, if your input is the program, you have to trust the person to put in a program that's not going to violate your secrecy. So this,
but that's also where MPC actually shines, because on MPC you actually have multiple parties, and they're supposed to agree on the code that they're running. And that's why FHE doesn't get the same guarantee.
But it's the input of one party.
If one of the parties input a private program, you wanted to keep the code secret, MPC could do that. It might not be something you want to do, but it could do it.
I think what
Yes.
Dan was saying was that MPC can also run metrics or other
Yeah,
validation code on that code as well.
Of course.
So to make it something more practical, I'm very toward practicality. One thing that you can do to make it simpler is that if you can have family of codes, let's say I can only handle 5 different codes, then you can choose an index instead of really putting the code as the input. You can have an index as the input, and it makes your life of validation easier.
Great. Well, we're getting real close here. I'm going to bring up one more question. And so that is, we know that there are many anonymization techniques to avoid a data breach. But how are the bad guys still able to retrieve the sensitive data from anonymized data? And how does MPC change this?
So one thing I always like to kind of bring up when I talk about MPC in comparison to some of the sort of data release protection techniques. When I release data, you know, I want to anonymize it, I want to add noise to it or something to protect it. It's important to emphasize that MPC and to a certain extent homomorphic encryption and even trusted execution environments, they offer a level of protection that is far beyond what the anonymization techniques offer. So a lot of the kind of attacks that you've seen on anonymization, pseudonymization, and sort of data removal, essentially, techniques do not apply to these 3 core technologies that are sort of general purpose and have these features. And in the case of MPC, you can go even further. So some forms of MPC rely on something called the one-time pad, and that is actually the strongest possible form of encryption that will ever exist. So this is something people don't realize. This isn't a matter of, you know, maybe someone will invent something that will break the one-time pad sometime in the future. That's just not going to happen. And that's something that's really interesting, because in some use cases, it is possible to use a one-time pad-based version of MPC, and that will offer you the maximum level of protection that you can ever have in the future, making MPC, in those cases at least, definitively future-proof.
There's also there's a ton of papers that have been published about re-identification of anonymized data. I think one of the best ones that I've seen for more a general audience was in Nature, I believe last year. Anonymity takes more than protecting personal details. So if you want to search for that, it gives a good reference of the vehicles that attackers use for re-identification.
And there's something that has to be taken into account is anonymization is 2 different things depending on whether lawyers or data scientists talk about it. When data scientists talk about anonymization, it's usually meant that they transform the data into a new form which somehow doesn't allow you to re-identify an individual. Whereas when you talk to a lawyer about anonymization, then they don't put a technology next to it. So it might be that sometimes in the future we talk about anonymized computing, and that's what MPC is. That depends on whose standards and whose terminology will win. So from a regulatory standpoint, we might actually want at some point that MPC would be considered as anonymization of some kind so that we could fit in with the regulations better. But we are not there right now.
Okay, excellent, excellent.
I think this is what was driving the EDPB's recommendation for the use of MPC under GDPR, right? Is the equivalence, or actually meets and exceeds the threshold of anonymization with MPC. So it's great to see European Data Protection Board actually recommend the use of MPC for compliant data processing and transfer.
Yeah,
precisely.
Okay. Well, it's hard to believe, but an hour has raced by on us, so we need to wrap up, even though there's quite a few questions here. So as we close, a couple of things. One, through the Bright Talk platform, we've got quite a large number of companies that have sponsored to put this event on. Obviously, Facebook is our platinum sponsor. They've got a booth. CPR is our gold sponsor. They have a booth. And we've got a couple dozen MPC Alliance member companies that have all come together to sponsor this event. And many of those companies have booths set up. So I want to invite you to stop by, visit those booths. You're going to find white papers, case studies, all kinds of interesting information there. You can also, contact them. So please visit all the sponsor booths. And number 2, we've got, again, these virtual meeting rooms that are going to be going for the next hour. So there's 3 virtual meeting rooms, one with Facebook where you can go in and ask Manush and some of the others on the Facebook team some specific questions around the Facebook's implementation with MPC. And CPR also has a meeting room where we can address any questions that you've got as a gold sponsor. We've got that set up. And then the MPC Alliance also has a meeting room. So if you have any questions about the Alliance or networking to find out what companies are working on what things that you might be interested in, I invite you to stop by any of those. But most importantly, I really want to thank the people who tuned in today and our speakers, both earlier today and on this panel session. You guys have been fantastic. Just kind of wrapping up on behalf of the MPC Alliance, what we found is MPC is really gone through a pretty material shift here in the last couple of years. It's been a subject of intensive study for literally decades. But it's quickly transitioning from a field of study to a field of implementation. We're now seeing literally hundreds of companies that we know of that are using MPC in their networks today, and we're seeing adoption increasing. That's why we felt it was the right time to do a conference like this to bring more awareness. This is the first of what will be 3 live events around this topic, and so we'll be in touch through Bright Talk, but check back periodically. This conference will effectively be open for a full year. So you can reach us, contact us through this conference, and we'll provide more information on follow-on things. So with that, I think we'll call it a wrap on this side. And again, I thank everyone for joining us today.
Thanks, Craig.
Thank you.
Thank you.
very much.
Thank you.
Thanks, guys.